Hey guys, Mr. B here again, bringing another wicked awesome math video. This one, another video in my calculus series on solving indeterminate form limits. This one using the conjugate. So we've already done a few different types. We've done factoring, sum and difference of cubes. So today we're taking another big step and we are doing the conjugate. All right, let's get started. So first of all, before we actually jump into doing an actual limit, you have to figure out what the conjugate is. So the conjugate's a pretty simple concept. And basically, if you have a binomial, let's say, for example, root x plus 3, if you want to conjugate it, you multiply it by, and we'll put it in brackets here, multiply it by root x minus 3. So all you do is change the middle sign to the opposite. So in doing that, you create this FOIL situation. So first outside, inside, last. But in reality, you do not have to do the full first outside, inside, last. Let's just go through this and try and see what happens. So if I do root x times root x, I multiply together to give me just x. And then I do root x times negative 3. That gives me negative 3 root x. And then I do root x times positive 3, which is plus root 3x. And then the last, you end up with 3 times negative 3, which is 9. So that's my first outside, inside, lasts. So what ends up happening, of course, is the O and the I end up canceling. So those two middle terms are exactly the opposite, which is why we do the conjugate in order to make that cancel. And then we end up with x minus 9. So that is the first and the last term. So in my class, what I tell students is when you're doing the conjugate, you don't do FOIL, you do FLA, which is first and last. So when we're doing the conjugate, we're going to do FLA, basically, all right? So when I say FLA, it means first and last. All right, so we got a limit here. And first of all, like I said in my other videos, even though I hate wasting time at this, but I will do it because you might have some stingy calculus teacher or professor out there who says, oh, you didn't show all your workings or whatever. So let's go ahead and check to see if this is indeterminate form first. So all you need to do is sub in that negative 1 into the equation like this and do the quick little bit of math. And in the top we have root 1, which is 1 plus negative 1, so that's 0. And on the bottom, of course, we have 0. And this is our indeterminate form, right? Indeterminate form. So basically what we have is we have to do something else, right? So that 0 over 0 tells us that we have more work to do. So when we have a root involved in a finite limit, and when I say finite, I mean it goes to a number, generally that method is the conjugate. So that's what we're going to do is we're going to take the conjugate of the top of this thing, because that's where our root is, and then hopefully something will cancel, and that something, you should already know what it is, should cancel. And we'll be able to get a definite answer for our limit. So when I say you should already know, I'm assuming you watch my other videos, but you can tell in a limit of indeterminate form what's going to cancel. So this limit goes to x minus 1. So that means I want to cancel the factor x plus 1. So that's what we're looking to happen. And you can see that guy's already on the bottom, so we just need to somehow get it from the top. So let's go ahead and see if we can't do some magical mathematics and figure this thing out. So I'll rewrite my limit just so I don't have to get too messy here. I'll write my limit, and then I'm going to take the conjugate of the top. So remember, all the conjugate is changing the sign between the two terms. So my two terms is this root, so that's my first term. And then my second term is the x. So it's just root x plus 2 minus x. And that's all I do. Okay? And then you can put, actually, I'm not going to do that. I'm going to put the entire top in brackets. just so it's a little bit easier for us to expand out. And then I'll do the same with the bottom. I'll put the x plus 1 in brackets, and I'll rewrite this, root x plus 2 minus x. So remember, my technique with this is that we follow the part that we're conjugating, so that's first last, and then on the bottom where it's not conjugated, we still multiply the top and bottom by that conjugated version of the top, but we do nothing. We don't do anything. We want to make sure we leave this x plus 1 alone to make sure that it's left by itself to get canceled out. So let's go ahead now, see if we can't make this guy work out. So I got root x plus 2, so that's my first, times root x plus 2, and it's magic. All that happens is my root disappears, so I end up with the radicand, just like that. And then I end up with, so I got root x times a root x, which is negative x squared, just like that. And then on the bottom, I end up with x plus 1, and then all I just do is kind of neatly push it together underneath in the denominator, just like that. So unfortunately with this one, we don't get something nice and neat that cancels right away. We get a quadratic. So I need to rearrange this, and I'm just going to do this out to the side, rearrange this like this. So x squared, and then it's plus x plus 2. All right, so I've got something that I need to factor, and I'm just going to rewrite that right there now, plus 2. So I'll put that negative x squared right out in front, and we're going to try and factor. Now, if you've had me as a teacher in class in person, you know my philosophy when it comes to quadratics is I never, ever, ever leave a negative in front of the x squared, no matter the situation. Okay, it's just like a personal thing. And for me, it always makes the factoring just a little tiny bit easier. So if I do that, then I end up with x squared, then minus x minus 2, just like that. All right. And on the bottom, nothing changes. X plus 1, root x plus 2, and then minus x. So now I'm ready to use the AM method, as I call it, add, multiply, or like some people call it, product sum. So it's what adds to give me negative 1 and multiplies to give me negative 2. So the numbers that make that work, well, negative 2 plus 1 is negative 1. And negative 2 times 1 is negative 2. So that those two numbers satisfy it. So then all I got to do is put them in their factored form. It's not a 21, that's a bracket. And then x plus 1. All right, so now I'm ready to rewrite this. And you can see how I got that x plus 1 out of the top. So hopefully we'll be able to make something work out of that. So we end up with negative x minus 2. And then x plus 1, and then we divide that by x plus 1, and then x plus 2 minus x. So one of the mistakes that I see often with students is just copying stuff down wrong. Somehow these signs change on the way down. A lot of times you'll see them convert back to plus and things like that. So just be extra cautious with this stuff, that we don't make any silly mistakes, because that's where people lose their marks a lot of the times. It's not knowing how to do it, it's just mental mistakes that we can avoid. So we cancel out, and I'm famous for that too, of course. I'm the king of mistakes. So we cancel out the x plus 1s just like that, and now we'll rewrite the limit. This is kind of an optional step. I like to do it, you know, just to always never give your teacher or professor or whoever it is, especially if they're cranky, a chance to take marks off, right? So a lot of teachers are, they make decisions out of the wrong reasons, or take marks off for silly things. So just don't give them a reason, basically. Don't leave it in their hands. Take all the chance out of it. All right, so now once we cancel out that indeterminate form, we've literally taken out the 0 over 0 that we initially had. And again, we knew that was going to cancel from the beginning. Once we do that, we are ready to rock. by subbing in that x equals 1. And if we did it correctly, which I think we did, we should get something nice and neat to work out. So just be very cautious with the signs. There's a lot of negatives floating around. So I got -1 subtract 2, which is -3, but then I have that negative out on the outside, so that's a 3. And then over here I got -1 plus 2, so that's 1, square root of 1, which is 1, and subtract -1, which is going to be 2. So there it is. There's our limit. So all that work, and this thing works out to be nice and neat as a 3/2. All right, so let's go ahead now, look at another example. This one's a little bit harder because it is got a little bit more work involved with it, but the philosophy remains this exact same. That's what you think about these limits, is that, like, overall, they're all a little bit different, but like the different techniques have their same philosophy involved in all the answers. You just have to take your time, think about the ones that you've practiced, think about this one, and they'll work out pretty much the same. It just requires a little bit more work. So obviously you can see this one, the numbers are a little bit bigger. We got something a little more complicated on the bottom. So let's see what happens. So I'm not going to waste my time with this one and do the 0/0. We're going to assume it because I made the question. And we're going to start right away at the conjugate. So we know it's a conjugate because there's a root involved. It's 0/0. So therefore we have no choice but to try and conjugate. So I'll put the top in brackets. And it's just a fluke that this one's the top is like a good example that I saw in my notes that I decided just to grab. It could be the bottom as well, so don't think that conjugates only comes from the top. Nope, you could have a root on the bottom that you have to conjugate. All right, and also be very careful that you don't conjugate the wrong type of limit. These are finite limits, so they go to a number. Infinite limits, limits to infinity, there's a whole different technique for that. I'll drop a video in the description if I remember. So let's do our fl and nothing. All right. So remember, the one that we're conjugating, we fl. The one that we have on the bottom here, we do nothing. Even though that's not completely 100% true with this one, but initially we'll do nothing. All right. And we're expecting x plus 1 to cancel. All right. That's our goal, is for that to cancel. Or sorry, x minus 1, not x plus 1. It's always the opposite sign, right? Because it's like the factor. So let's go ahead and rewrite this guy. So we got limit. So let's go. 4x times 4x is 16x squared. So 4 times 4 is 16. X times x is x squared. And then we have our limit, or sorry, our root here that multiplies. So this is the last term. So these terms will always be separated with the minus sign. We got 10x, root 10x plus 6 times root 10x plus 6 is just 10x plus 6. So that's the f, that's the L, always separated with a minus sign. And then here on the bottom, I got my 3x. And you might be thinking, like, you could probably do something to that. I can take out a 3, or a -3 would probably be actually more useful. And I know I'm going to do that. But for the first step, I follow my fl and nothing. And that's one of the things that I don't want you guys to sort of freak out. Like, when you're doing these questions and maybe you're getting one on a test or something that you've never seen before, you haven't done one like it, let's follow the philosophy, which is fl and nothing first. And then we'll see what shakes out the rest of the way. And with these limits, sometimes you got to be patient and just let it come to you, let it develop, all right? So on the top, I want to sort of see what I can work out in terms of getting rid of this bracket. So there's a minus in front of here. So when you have a minus in front of your second bracket like this, you have to watch the sign, and this thing is going to change the sign of the 10x, but also the 6. That second negative is easily forgotten about. If you're unsure, treat it like distribution. That negative goes here, the negative goes here, and changes the sign. All right. And then I'm not taking that -3 out just yet. I want you guys to wait and see. Like, I know it has to happen, and maybe some of you do, but maybe some of you don't. So let's just be patient and wait till we get the top factored in order to see what works out. So this top is factorable. So I can take a, let's see, I can take a 2 out, and that will make the factoring slightly easier. So that's another one of my rules, is that I always check for a common factor. No matter how simple the factoring technique might be, if you can take a common factor out, make your life that much easier by doing it. So I take out a 2, and then I'm left with this. And in general, if I have complicated factoring situations like this one, I try not to do my workings within the limit. I might do them out to the side. It just makes things a little too complicated, and rewriting the bottom continuously just opens up the opportunity for like a ton of mistakes. So you want to be extra careful, and I'm using the Barnes method. All right, so, well, technically it's the Barnes-Fury method, and if you guys know Miss Fury, which I'm sure some of you do not, she's amazing, and we share a method, but I'm stealing it for today, Barnes method only. So it's what adds to give me the middle term, -5, and multiplies to give me 8 times -3, which is -24. Okay, so I need to figure out two numbers that make that work. So the two numbers would be -8 plus 3 is -5, and -8 times 3 is -24. So if you're doing a calculus course, guys, I assume that you sort of have the mental math ability to be able to do this, even though that's not a very nice thing to say. So maybe what I should have said, if you're doing a calculus course and you're struggling with a few of the factoring techniques, then that will be a place that you might want to focus your energy, because there are a lot of factoring techniques in calculus, whether it's you're doing, curve sketching, things like that, ton of factoring stuff. Luckily, you know a guy who knows a lot about math, so go to my channel. I got a ton of videos, and maybe I can put some in the comments down below. If you drop me a like, I might, or a subscription. So yeah, so let's go ahead. So it's x minus 8, and then it's x plus 3. All right, but with the Barnes-Fury method, the tricky little bugger, you have to divide by the leading coefficient, which in our case is the 8. So when I do that, I get x minus 1. Will you look at that? This little guy popping up again. And then this one, not so fun, 8x plus 3. Okay, so that 8 goes up in front of that x to get 8x plus 3. So now I'm going to come over here, and I'm thinking, okay, I got my x plus 1 in the top. Can't forget that 2 there, guys, okay? That 2 got to stay. I got my x minus 1, in the top, and I need to get x minus 1 in the bottom. I know it's not going to come from this mess of a root over here, so it has to come from the little expression that was there previously. So if I take a -3 out of this expression, -3 comes out, and what I get left with is, well, that -3x becomes positive x, and the positive 3 gets divided by -3 and becomes -1, and you look what happens. I get that to work out. So it's all about being patient, trusting the techniques, which is fluh and nothing, and then knowing what's going to cancel. Look at this, guys. It's like slapping you in the face with a giant hint for this question. So if you cancel something other than that, you know you messed up. And chances are you messed up with a factoring technique or something along that lines. So I'm going to cancel those x minus 1s. And then I've got the limit as x goes to 1. And I'll write that 2 right there. 8x plus 3, all divided by -3 on the outside, 4x plus square root 10x plus 6. So now, once you factor, you are ready to rock this thing, and we're going to sub the 1 in. So I got 2 on the outside of 8 times 1 plus 3, all divided by -3 on the outside, and then it's 4 times 1 plus square root of 10, 1 plus 6. So chances are your calculator or your calculus class is non-calculator. So if that's the case, this is a pretty good question to be able to work out, mentally. And as always, just take your time. Don't get frustrated and be freaked out. do small stuff. So like the brackets here is 8 times 1 is 8, plus 3 is 11. So you can do that first. And then we'll do the brackets down here. So 4, maybe I'll do this 4 first, and then plus, so that's 10 plus 6, which is 16. Square root of 4, square root of 16 is 4. So then I end up with, on the top is 22. On the bottom I got 4 plus 4 is 8, times negative 3 is negative 24. And then you're thinking about what you can divide by. So I don't like the negative on the bottom, so I'll just kind of move it out equal to the divide sign. I'll divide by 2, divide by 2, so that's 11 over 12. And there you have it, guys. Another question done on Math with Mr. Barnes. Just want to thank everyone for watching. If you stuck around for the entire video, I appreciate that. Hopefully it helped in some tiny little way. If it did help, you know, I'd love you guys subscribe, drop a like, drop a comment. What do you want me to do with my channels, or any topic that you'd like me to cover? Anything I can make it more fun, interactive, anything like that. Thank you guys for watching, and I'll see you guys in class.